Hello guys, this is Prime Concept. We want to further our learning on refraction through lenses. In our previous video, we considered the introduction to lenses. We explained the two types of lenses that we have and then the focus of our studies. We mentioned that we have our convex lens, which is also known as converging lens. We also established that we have our concave lens, which is also known as diverging lens. And then we also established the rules that governs the ray diagrams for image formation. In this video, we want to look at the image formation when objects are placed at different positions. We'll consider them one at a time. In this video, we're going to consider when our object, which is our first, when object is at infinity. So when object is at infinity, when our object is at a very far distance, where will the image be formed? Now we are looking at image formation, of course, for our convex lens. So I think I should write it. I should write that image formation for convex lens. So this is for the convex lens, and the first position of our object is when our object is at infinity. So when the object is at infinity, where will the image be formed, and what will be the properties of this image that is formed? So we want to look at it. So this is our lens, our convex lens. This is our convex lens. So for which you know already, we have this point which is f2, and we have this point which is 2f2. We have this point, this is f1, then this point which is 2f1, right? Now, following the rules, like I mentioned, we have three rules which I outlined in the previous video. So we're going to use any combination of two that is convenient for us. So I want to use one of them. Remember, when we mentioned that object is at infinity, in physics or in ray optics, infinity is also always denoted with parallel lines. So whenever you see parallel lines, when you're dealing with the concept of optics, simply means that that object or that image is coming from infinity, is at infinity. So I want to mention my object at infinity, means I will use parallel lines to denote that object, which you cannot actually see. So if I have this, then I have another. Of course, if I draw this, when it hits the center of my mirror, what will happen according to one of the rules, which is the third rule I mentioned, it will come out parallel to your principal axis on this side, right? Now, if I follow the other rule through the optical center, so I would have this. So you can see that these two lines are parallel, meaning that that is our object coming from infinity. So these two lines parallel means object is at infinity. Now when this hits, according to the rule, what will happen? It will go straight. It will go straight undeviated, because my line is not drawn to scale, so pardon me. It will go straight undeviated, right? Yes. So let me make it proper. So it will go straight undeviated. So this is the rule. And when your object is at infinity, you will notice that where the two lines meet, where the two refracted rays meet, is where our image is going to be formed. So our image is going to be formed at what point now? It's going to be formed at the focal point. Our image is going to be formed at the focal point on the other side, right? So we can outline the properties of this image that is formed. So what are the properties? Number one property of this image that is formed is that, of course, compared to our object, our image is what? Diminished. Our image is diminished, or it is smaller than the object. So number two is that you can obviously see that your image is what? Inverted. So our image is inverted. Number 3 is that, of course, we established in our mirror studies that when you have an inverted image, you expect that that image should be what? Real. So our image is what? Real, right? So you should know now, as a matter of consideration, that for lenses, when your image is formed on the opposite side of your object, it simply means that your image is real. So this is where our object would always be located. Anytime your image is formed on this side, it simply means that your image is what? Is real. So that is why our image is real. Do we have another property? We have our image is diminished, it is inverted, it is what? Real, right? Yes, and then I think these are the basic properties. And then finally, number 4, image is formed at focal points. So our image is formed at the focal point. So what is it now? When our object is at infinity, the image is formed at the focal point, the image is diminished, the image is inverted, and the image is what? Real. So these are the properties you need to know when your object is at infinity. I believe this concept is really very clear to you. I would encourage you to try to draw this diagram using your scale diagram to do this. You'll get the exact location. I'm using freehand. That is why it might look rough like this, right? Thanks for watching my video. Thanks for always supporting me. Remember, this is Prime Concept. I'll do the next one in the next video. Thank you.